This video is called Adding and Subtracting Rational Expressions. That's exactly what we're going to do. We've got a rational expression 4x over x squared plus 6x plus 8 minus all of 3x divided by x squared minus 3x minus 10. Okay, don't want to forget my equal sign. And that 4x isn't going to change for now. But on this denominator, on the side here, I can factor x squared plus 6x plus 8. I'm looking for what multiplies to 8 and adds to 6. Please watch the video on factoring using Bergman technique if you don't know what I'm doing. Multiplies to 8, adds to 6. The numbers are 2 and 4. So on the bottom here I get x plus 2, x plus 4. Make sure that fraction goes the whole way. Take away, the 3x doesn't change. And on the bottom I have x squared minus 3x minus 10. That also can be factored using Bergman technique. What multiplies to negative 10 and adds to negative 3 in my head? The numbers are negative 5 and 2. So this bottom becomes x minus 5 and x plus 2. So the factoring is done. I'm going to put these in boxes, just I like the way it looks. It's grouped a little better. And to help me find my work later if I need to reference it. Factoring done, the next thing I want to do is record my restrictions. Restrictions are what can't the denominator be? That would be anything that makes the denominator 0. So in this case, x can't be negative 2, that would make this denominator 0. X can't be negative 4, that would make this part 0. X can't be positive 5, that would make this 0. And negative 2, I already got it, so I don't have to record it again. So factor, record my restrictions. And the next thing I need to do is common denominator. I'm going to write down all the things a denominator needs to be a common denominator. This has an x plus 2 and an x plus 4. This has an x minus 5 and an x plus 2. So what's missing? I've got an x plus 2 and an x plus 4. This one already has an x plus 2 and x minus 5. So in other words, what I'm going to need is everyone's going to need to have an x plus 2 and an x plus 4 and an x minus 5. They all need that. So now that I've got this common denominator shown, you have to show this. Please show your restrictions, show your common denominator. That's why I'm going to multiply this by the common denominator it's missing. So multiply the top and the bottom by x minus 5. And I'm going to multiply this one by what it's missing. It's got the minus 5 and the plus 2. It's missing x plus 4. So I'm going to multiply top and bottom by x plus 4. Alright, let's do that. So on the top here you get 4x times x minus 5 all over the common denominator, x plus 2, x plus 4, x minus 5 minus 3x times x plus 4 all over x minus 5, x plus 2, x plus 4. You notice I didn't write them in the same order. That's okay. There's still a common denominator, so because they're all multiplied together. And that's good because my very next step, now that I've got two denominators the same, I can combine them into one fraction with one common denominator, x plus 4, x plus 2, and x minus 5. And on the top here, I can start to simplify now. 4x times x, that gives me 4x squared. And 4x times minus 5, that's minus 20x. When you're simplifying here, we're foiling or distributing. Make sure to take the minus with you. Minus 3x times x, minus 3x squared. And minus 3x times 4 be negative 12x. So we get 4x squared minus 3x squared. That's just x squared. That's nice. And negative 20x minus 12x, minus 20 minus 12 is negative 32x, all over x plus 2, x plus 4, x minus 5. Show that fraction again. We should factor the numerator to make sure it doesn't cancel with anything in the denominator, but this factoring is easy. It's just common factoring. What goes into x squared that goes into x? Just an x. Need my equal sign. I get x times x minus 32, I just factor out an x, all over x plus 2, x plus 4, and x minus 5. Now I'm really glad I put these boxes here. It keeps my work looking neat. Except I'm not quite done. I have my final answer, and it looks nice like I just said, but I'm not quite done. I need to state my restrictions. That is, when you get to this final expression, there's nothing left to do. Nothing cancels out, so it looks like I'm done. And I'm kind of squished out of room here, so I'm going to put a little arrow down here. You don't have to rewrite the question. I'm just out of room. So x minus... Just rewriting it down here so you can see a properly formatted answer. Okay, there's my answer, comma, state my restrictions. What can x not equal in order? X cannot equal -4 is the smallest thing, then -2, then 5. Here's my final answer. X over x times x minus 32 over x plus 2, x plus 4, x minus 5, and x cannot equal -4, -2, and 5 in order. We're done. We've added and subtracted, in this case subtracted, rational expressions.